In this lesson, we are going to talk about the key features of exponential functions. And the key features of exponential functions are the a and the b value. So we've already looked a little bit at equations, tables, and graphs. Now we're going to go into a little more detail. So for equations, the a is your initial value or your y-intercept. So this is your initial value or y-intercept. Your base is the number that is being multiplied over and over. And then, of course, you have to have x as an exponent. It is very important that the variable, even if it's not an x, it could be an m, it could be a t, it could be an s, it can be any variable as long as it is a variable in the exponent. Then we move on to tables. Now tables, when you're given a table, you can tell that it is exponential by seeing if you are multiplying to get from one y value to the next, or if you're adding or subtracting, then it would be linear. So from a table, we can tell where the initial value is because that's wherever x is 0. So those would be our initial values. And then the base is the number that you multiply by over and over to get from one y value to the next. Now, if you're dividing over and over, so here you can see how these values are decreasing. If you're dividing over and over, then your base is just going to be the reciprocal of that value that you would be dividing. And finally, for graphs, the initial value is the point where your curve crosses over the y-axis. Your base is still the number that you're multiplying to get from one y value to the next. So if it's growth, then to get from 2 to 8, I would be multiplying by 4. That would be my base. In the next example, to get from 8 down to 4, I would be dividing by 2. So that would be the reciprocal would be my base. So instead of 2, it would be 1/2. And again, x is just your independent variables. Now let's do some examples. So in the first half of these examples, we are going to use the initial value and the base that's given and write an exponential equation from it. Then we're going to determine if it's growth or decay. So remember that the equations are always in the form y equals a times b to the power of x. So for number 1, we have y equals, we're going to write a times b to the power of x. Now, I don't really like having so many dots, so instead of writing the dot right there, I'm actually going to put 0.5 in parentheses, and you will see that sometimes. Now we have to state whether it's growth or decay. Since our base is 0.5, that's between 0 and 1. So that would represent decay. Example 2, y equals a times b to the power x. So y equals, our a is 4 times the base of 2 raised to the power x. Now my base is 2. And that is greater than 1, so this is going to represent growth. Then in examples 3 and 4, we have the equation and we're working backwards. We want to know from this equation what is the initial value and what is the base. Then can we tell if it's growth or decay? So in number 3, our a value is 2. Our b value is 5/3. Now, is this growth or decay? Our base is 5/3. But just because this is a fraction does not mean that it is decay. 5/3 is actually the same thing as 1 2/3. And 1 2/3 is greater than 1. So since our base is greater than 1, that represents growth. In example 4, our a value or our initial value, the y-intercept, is 1/2. The base is 0.3. Since this base is between 0 and 1, that represents decay. All right, now let's look at some tables. So we're going to determine whether it's growth or decay, and we're going to write the equation based on the tables, which means we have to find the key features, the A and the B. So in number 1, it starts off, the first value is a decimal. That's okay. We can still find the trend or what's happening from each y value to the next by looking at those whole numbers. So from 2 to 10 and 10 to 50, what is the common change that happened through multiplication? They were multiplied by 5. So since we're multiplying by 5, that is our base. Then we want to find our initial value. Your initial value is always where x is 0 in the table. So our a value is 2. So our a value, our initial value, our y-intercept is 2. Our base, or the number that we're repeatedly multiplying by, is 5. And we can tell that this is definitely growth. First, we knew it was growth because these values are increasing. And then our base, which is 5, is bigger than 1. Now we want to write this equation in the form y equals a times b to the power x. So y equals 2 times 5 raised to x. Right? In example 2, just looking at these y values, I can see that they are decreasing. So this is going to be a decay function. Now, if this is decay, I have to remember that my base should be between 0 and 1. So what number am I multiplying by over and over? Well, at first glance, I can't see that I'm multiplying by anything, but I can see that I'm dividing by 3. Well, if I'm dividing by 3, my base is not 3. Okay, my base is actually equal to the reciprocal of that, 1 over 3. And the a value, the initial value, is going to be 9. So our y-intercept is 9. Our base is 1/3. So our equation is going to be y equals 9 times 1/3 raised to x. In example 3, I can see that my y values are decreasing, so this should be decay. And knowing that this should be decay, I have to think to myself, my b value should be between 0 and 1. Okay, let's go ahead and find the a value for this one, since it's right up here at the top. Where x is 0, my a value, or my y-intercept, my initial value, is 8. Then the number that I'm multiplying or dividing by each time, well, from 8 to 4, from 4 to 2, and 2 to 1, I'm dividing by 2. Well, if I'm dividing by 2, then my base is the reciprocal, 1 over 2. So my equation is going to be y equals 8 times 1/2 raised to the power x. And finally, example 4. This time I can see from 12, 48, 192, those values are increasing so quickly, so much, so fast. And that's kind of where this term exponential comes from. It is increasing exponentially by a factor of multiplying. So from 12 to 48, what is my change that's happening? How am I multiplying over and over to get that value? Well, 12 times 4 gives me 48. 48 times 4 gives me 192. 192 times 4 gives me 768. So I can tell that my base is 4, but I don't have a y-intercept given here. We don't know if x is 0, we aren't given that y value. But we can say what number times 4 would give me 12. Well, that would be 3. So my y-intercept is going to be 3. Okay, so this is definitely a growth function because we talked about how quickly those y values were increasing, and our equation is going to be y equals 3 times 4 raised to x. Now we're going to look at graphs. Graphs are a little bit trickier just because you don't have them laid out nicely for you in a table, but we get the same information in pretty much the same way. In number 5, we're going to start by just identifying the y-intercept, the a value. So a is always where your line or your curve crosses the y-axis, and this happens to be at the value of 3. Okay, now to find my b, I've got to find some perfect points. So I see some perfect points here. Okay, and basically all I have to do is determine what am I multiplying by to get from one y value to the next perfect point's y value. All right, so from 3 to 6, if I'm going to multiply and get from 3 to 6, I'm going to have to multiply by 2. So my base is going to be 2. Now I can tell that this is definitely a growth function because as I trace this from left to right, that is going up and that forms kind of a J shape. So this is definitely growth. And we want to write the equation for this graph. Since we found a and b, all we have to do is write y equals, a was 3, our base is 2, raised to the power x. All right, let's look at example 6. Okay, again, I can tell that this one's going to be growth because as I trace from left to right, it goes up, or it's increasing from left to right, and it forms that J shape. So this is definitely growth. And we want to find the a value and the b value so that we can write the equation. Now the a value is where the line or the curve crosses the y-axis. It's your y-intercept. So that's 5. B is what number do I multiply by to get from one y value to the next perfect point's y value. So from 5 to 15 to 45, what am I multiplying by over and over? That would have to be times 3. So my equation is going to be y equals 5 times 3 to the power x. Then number 7. Now this one is a different shape. It's going down when I trace it from left to right, forming an L. So this one's going to be decay. I still want to find a and b so that we can write the equation. Well, a is wherever my curve crosses the y-axis. My y-intercept is 4. All right, so finding some other perfect points, and locating those y values is going to help us determine the base. Well, since this one is decreasing, now I have to think about, as I go from left to right, how am I going down, or what am I having to divide by to get from each y value to the next? So from 36 to 12 to 4, that's division by 3. So if I'm dividing by 3, that's actually multiplying by 1/3. And I have to remember that since this forms an L, since this is decay, I have to remember that my B has to be between 0 and 1. Now my equation is going to be y equals 4 times 1/3 raised to the power x. And finally, example 8. Again, this one forms an L. As I trace from left to right, it is going down. It's decreasing, so that's decay. We're going to find A and B. So if I'm looking at the y-intercept, the initial value, the point where this line or this curve crosses the y-axis is a little bit hard to see here, but notice that each box or each unit is actually going up 20 values. So this isn't here at 20 yet. It's actually about halfway at 10. So our A value is 10, our initial value is 10, and to find B, we're going to have to find those perfect points and see how do we get from one y value to the next from left to right. So starting with the leftmost point here at -2, 160, that y value of 160 goes down to -140. So 160 to 40 is division by 4. And then from 40 down to 10 is also dividing by 4. But division by 4 is the same as multiplying by 1/4. So our B value is 1/4. Now our equation is going to be y equals A times B raised to x. So A is 10 times B is 1/4 raised to the power x.